Now that we know how to edit files, let's take a look at how we control access to files by using permissions. The idea of ownership is baked into Unix. Everything that's in your home directory or any subfolder of that home directory is yours, is your property unless it's marked otherwise. Things you own, you are free to change or delete. They're your property. You can do whatever you want with them. Other people's stuff, on the other hand, they have the right to control who can see what. And we're going to talk about this whole business of permission. And we'll do a little demonstration of how one sets up a website. It's a pretty straightforward and simple thing to do. So, in Unix, there are 3 rings of permission. U, the user, G, the group, O is others or everyone else. Now, to learn about permissions, let's do this. Let's do an ls-l on a file, say our sampler file. This thing over here on the left is called the permission string. It tells what kinds of permissions are given to the 3 rings. Now, this initial dash is either from the files that you're going to see are going to be a D or a dash. D means directory. If I do ls minus L bin, oh yeah, let's just do an ls minus al. And you can see, whoops, oh yeah, I guess we've put a lot of stuff in here. You can see that every time something's a directory, it has a D there. And when it's a regular file, it has a dash. Okay, well, let's clear all that stuff away. All right, now let's go back to our sampler file. So the first 3 slots are the user permissions. That's your permissions. I, as the owner of this file, have the permission to read or write. My group also has permissions to read or write, but on this machine, I and my group are synonymous. So that really doesn't make a difference. You might only want to have read permission for your group, depending on whether you want them to be able to write the file or not. Finally, others have permission to read that file. Okay, so we have permissions on sampler.txt. Now, one thing we should do, take a look at, is let's go up. I'm going to scroll up to dot here. These are the permissions on my home directory. And right now, it says DRWX. X is execute permissions. Okay? That means that I have read, write, and execute permissions. Now, why do you need execute permissions for a directory? Because you cannot see through the directory unless you have execute permissions. Okay? So you need to have execute permissions on a directory. You can block others from seeing through to your stuff. You'll notice that this person does not allow, Fake22Z, and that's me, does not allow, as of now, for people to see through my home directory. So once that's blocked, they can't see inside of anything at all. In fact, I will show you that that is true, because I'm going to do this. Oh, I can't do that. I'm going to log out. Probably the easiest thing to do. Oh, come on, log out. Okay, I'm going to log in as Morrison, which is me. So I'm going to do ls tilde fake 22z. Remember, that is an absolute path to fake 22z's home directory. Permission denied. I can't see through that directory because as an other, I don't have permission to do that. Okay. Now, if I become a root user, which I am on this machine, I can go anywhere I want to. But a root has a duty to be discreet about what he does. You should not poke. If you are a root user, you shouldn't be poking around in people's files gratuitously. You need to use that power to solve problems. One thing in particular that you should note is that your system administrator never, ever needs to know your password to solve a problem. He will never ask you for your password because he has root permissions. He can get into your account anyway and fix the problem. Okay, so right now, people cannot see into my home directory. Now I'm going to go ahead and exit out of there, and I'm going to log back in as my fake 22z. And I'm back in. Okay. So you can see from that listing that people do not have permission to see anything. So if you give no permission for your home directory to others and to your group, none of them can see in. And that can be useful. But there are cases in which you want them to see not necessarily into the directory, but through it. Execute permission allows people to see through your directory, but not to see its contents. So how do we manage permissions? Let's make a sample file. All right, so I made a file called permissions. It's an empty file. And by default, when touch grinds out a file, it gives those permissions. So we, as the owner of this file, have the right to grant or revoke permissions. Now here's a very simple, all permission commands, all changings of permissions are done with the chmod, the chmod command. Okay. Now here's one way to do it. You can specify ring or rings. So let's say I specify group and others. And let's say I want to give them execute permissions. Then if I'm going to grant, I get a plus, not put a space in there, and I go X. And look what happened. All three rings, or the G and O rings, got execute permission. How do I take that permission away? Very simple. Now, notice, by the way, I'm using the up arrow key to scroll into previous commands. That is another useful feature of the shell. It remembers your command line history. So now when I list permissions, I've taken those permissions away. So this is one way to do permissions. You can, if you do this, plus X permission, and then you ls minus L, you will see that all rings. So you can give permission to all rings. You can revoke permission from all rings. Okay, so let's go ahead and look at that. Yeah. Notice the file turned green when I gave it execute permissions. Okay, all executable files are green. They come in green type. So when I list permission, I can see that there are no read permissions. Oh, permission denied. I've even cut myself off from reading my own file. All right. Now, that's one way to manage permissions. So in general, the form of the command is chmod, and then you can go U or G or O. Then you can go plus or minus, right? So you can choose one of them. All right. And then you can go R or W or X. Now, you can only use a plus or a minus, but you can use any of these three. And you can also do this if you want. A will do for all. Okay? And then you put the file name over here, and this is the general form of chmod, one form of chmod. Okay, so this is one way to manage permissions, but it can be kind of clunky. I might want to set all three permissions at once. Okay, and that is a different kind of game. And we're going to learn about it by doing a little experiment. First thing I'm going to do is I'm going to go chmod 000 permission. Ooh. So all three rings, none of them have any permissions. All right. So let's see what happens when I put a 1 in here. Right? I get execute permission. All right. Now let's put a 2 in there, And notice I'm just calling back previous commands and editing them. Ooh, I got write permission. Now let's put a 3 in there and see what happens. Okay. We're going to decode this by playing Mud Pies. Repeat the last command that started with an L. Ooh, I got W and X. You notice X is worth 1 and W is worth 2. So the only way to get a 3 there, you got 2 plus 1 is 3, WX. Now let's try 4 and see what it does. And then the surprises will start to go away. Here's 4. 4 gives me read permission. Okay? So I can change any of the permissions I want. Let's try 5 and see what happens. So I'm just changing the permissions on me. Read and execute. 4 plus 1 equals 5. Now let's try 6. You can probably guess what's going to happen here. Okay. Now let's try 7. Read, write, and execute. This is called, this digit is actually an octal digit. It's a digit between 0 and 7. Okay? X counts 1, W counts 2, R counts 4. And for every number between 0 and 7, there's only one way to represent it as a sum of 4 and 2 and 1. You can see that. That's how basic. That's a base 2 kind of thing, right? It's a binary kind of thing. So the first 3 represent my permissions, all right? Now, the second digit represents permissions for the group. So let's just do this just for fun, because we generally have the idea here. Okay, 5 is read and execute. So 0 is no permissions, 1 is execute, 2 is write, 3 is write and execute, 4 is read, 5 is read and execute, 6 is read and write, 7 is read, write, and execute. Okay, that works the same there. And then, so this can change all 3 permissions at once. It's very simple, and it doesn't matter what the permissions were originally. They are just going to be changed to that. That's it. Okay. So that's managing permissions. Now, you may want, in fact, you will want others to see through your home directory if you want to maintain a website. And I'm going to show you how the permissions work for that. To do that, what we do is we make a directory. Now, it's the nearly universal name for this directory is public_HTML. If you're not sure, you can ask your system administrator, but most places configure Apache, that's the web server, so that public_HTML is your web face. Now, here's the problem. Oh, let's do ls. Okay. ls-d suppresses the listing of contents of directories. So I'm just listing, and then I'm listing all files in long format. And I can see I have no permission of execute. So what I'm going to do is chmod 711 dot. And then I'm going to go back to LizDoll here. And I've given execute permission to everyone. That does not allow you to see into my home directory. It allows you to see through it. Now, what I need to do with public_HTML is that. Okay, now people can see through my home directory, and now they can read anything that has read permission in public_HTML, provided that I have read permission for others. Now you might ask, who's the other? On a Linux machine that has a web server, a typical web server that runs is Apache. There's another one called Nginx, but they do a very similar thing. Apache is a user on this machine that is not human. It's a non-human user, but it's an ordinary user. And when someone types in the web page, types in for your web page and makes a request, Apache goes to your account and looks for the files that are being requested. If Apache cannot see into your account, your website cannot be seen by the outside world. Okay, now I'm going to go ahead and go into public_HTML, and I'm going to put what's called an index page. On some sites, they call this home.html, but in this case, it's called index.html, and that's nearly universal. Now, what you do here is you type this funny looking stuff. All that says is the browser that asks for this web page is going to read this. And this says, hey, browser, I'm using HTML5, which is the current standard. This says I'm starting an HTML document with a language of English, American English. All right. Then inside of here goes a head. And here's a title. Now this is something that helps boost the efficiency of your website. Do it. Because when you write HTML, you use a validator. Validators check and make sure your HTML is clean, and that causes your page to load faster. So that's why you want to put that in there. So I'm going to close the head of the document. Body. Now things in the head are not visible. They're data about your page. Say for one thing, the title will show in the title bar of the browser. Now let's go ahead and put in something like H2. 22 Z's. Oh yeah, let's do this. Okay, so I'm making this web page, and you'll notice that there's syntax coloring galore. H is a headline. You will see that. Now I'm going to close the body. And that's a pretty minimal HTML page, but it'll validate. It'll look nice. All right. So there's my web page. Now, one thing I want to do with web pages is make sure they have 644 or, in this case, 664 permission just fine. That allows, the key is right over here. This read permission allows Apache to get this file. So when Apache gets the request, Apache is just a user. It goes and it grabs the index.html file and sends it out over the web to whomever requested it. Okay, so there's my index.html file. It is now put. Now I'm going to view this file. All right, this is not an outwardly facing, this is only a local server. And I have a virtual machine that gives me access to it. But let's go ahead and get a browser window. I'll make a new one. And I'm going to let me get it off my other monitor and bring it over here. And I don't need a very big one to show this page. Okay, so here it is. So what you do is get rid of everything inside of here. This is my blank page thing. All right, so if you have outwardly facing server space, oh, I went to me. I need to go to fake22z. All right. And there it is. There's the web page. Okay. And you can see here's where the title goes, right? Okay. So we have seen here that Apache can see through my home directory, but not into it. And I'll show you that my contents of my home directory are not visible to the outside world, but it can see through to the public_HTML, and it can get anything out of there that I give read permission to. Now, if I want to put something on a website and don't want it to be seen, I can chmod it to 600, and I have read-write permission, but nobody else, including Apache, does not have permission. So let me convince you that I'm going to go ahead and exit this session. Okay, so now I've gone ahead and done that. I can't see in there, but watch this. If I now go /public _HTML, aha. In fact, I can even do this. Oh, and I need to say ./index. And there's my index file. Okay, so others have permission to see the files in my web directory, but they do not have permission to see files in other directories. And you can actually put other directories within your web directory, and they would be accessed by ~fake22z and then the name of that directory. And if you put an index file in there, that's the file that automatically shows. That's the way the web server works. But you can see that permissions play an important role. They allow you to control who sees your stuff. It is necessary to understand them. So if you have an outwardly facing server and you want to have a web page, you need to be able to see through your home directory, and you need to be able to read and execute from your public_HTML so that things can be viewed by Apache. Apache grabs the file, it gets a copy of the index file, and it sends that file out over the web to the person that requested it. So that's Unix file permissions, you now know how to control what others see of your stuff.